In chemistry, there's many times a need to go from sort of the macro scale level, grams, to what we might consider the micro scale level, things you can't see. So number of molecules or compounds like water, H2O. But then you can go even further and say, well, H2O, I might have a desire to know how many hydrogens there are. So you'd have to times by 2 whatever number you had here. So if we had just a very small number, 10 water molecules, we know for every 10 water molecules there's 2 times that hydrogens, because there's 2 H's for every water molecule. So if I have 1, I have 2 hydrogens. If I have 10, I have 20. So I'd have 20 H's. And what's important in chemistry is to have a sort of method or a map or a process that you can work through to go from grams to moles, or moles to grams, or grams all the way down to numbers of atoms. So you'll see here conversions that are used, and it's not important to memorize, I don't think, the conversions, but just to realize that to go from moles to grams, you'll have to have a conversion that relates the moles of water to the grams of water. So for example, for water, we'd say every water molecule has a certain weight, and a mole of them, 6.02 times 10 to the 23rd, would be about 18 grams per mole. And we could use this conversion in many different ways, or 2 different ways. We could say, well, if I want to go from grams to moles, then I'd have to use the mole over 18 grams, because I'd be able to take the X grams and cancel that out and be down into the moles. I'd have my unit mole left. But if I want to go the other way, it's the opposite. So you're using these conversion factors as means to get from one point to another. So if I have to go from grams to moles to particles, let's say not just the moles of water, but I need to know the number of particles, then you start dealing with Avogadro's number, that 6.02 times 10 to the 23rd, and again using it in some sort of conversion factor. Point is, when you start a question, make sure you map. How far am I going? Is this a question that's asking for grams to moles? Or is it asking for grams to particles? Is it asking for moles back to grams? Kind of know where you're going, because if you don't know where you are and you don't know where you're going, you're not going to know how to get there. The journey is not the issue, or the middle is not the issue. You don't know where you are and where you're going. So map it out. Know the number. Once you do that, you'll know the number of conversions. It's kind of good to know, hey, I've got 1 conversion or I've got 2 conversions. And then just start with the one number usually given that's like what we call an extent. How much? How many grams do you have? How many moles do they start you with? And then convert that. And then just lay the conversion factors out such that you change that one number or measurement to what you want. And we'll show, let's just do an example. So let's take and say we start off with a question where they have 4.78 times 10 to the 24th nitrogen dioxide molecules or compounds. We know it's 2 different atoms, so we can call it a molecule, but more specifically it's a covalent compound. But they want to know what is the mass of this. So you can kind of say I'm shooting for the mass of NO2, and that's what my goal is, and you want to have it kind of set in your mind. But I'm starting from a numbers of 4.78, I'll put it all the way over here, times 10 to the 24th NO2s. All right. But now I need to know how many conversions. Well, if we look at our map, and this is again just a condensed version of what we saw here, showing a little more detail, we can say, hey, I'm not at, in this case, grams, I'm at number of particles, and I'm going up. So this is kind of just a general sort of use it whichever direction you need to go in. So really, I'm at particles, not at number of atoms. They didn't say 4.78 times 10 to the 24th oxygen atoms. They said particle we're treating as a compound. We're saying I'm going from the particle, not to the moles, but they want to know the mass. So I've got to go from particles, the numbers of them, to the moles, and then on to the grams. So I know right away now that I have 2 conversions that I need to use. So how'd you know that? Because I have 2 arrows. One from particles to moles, and then the moles to grams. And really, you need to think that way. If you get this down, sort of the map, the math falls into place. Let me show you how that works out. So we know we have two conversions, but now we know beyond that where our starting point is. And if we know its number of NO2 molecules, well, we can say, I know a relationship between the number of molecules and a mole. 1 mole of NO2 is equal to 6.02 times 10 to the 23rd atoms, or NO2s. We'll just say NO2 atoms. Well, that cancels with this, and we're now in moles. But we're not stopping there. We're going on in our calculation. We know for every 1 mole of NO2, it gives us, and you'll have to sometimes find this weight was determined by taking 1 N from the periodic table, and its weight, and then times the oxygen's weight by 2. So let me just show you where you would find that. You would say 14.101 for nitrogen, plus that 16 times 2. Why? Because it's NO2. So if you add that up, you get 46.006, we'll say, and we would put that right here, the mass of 1 mole of NO2. This is our conversion factor. And that's going to give us the weight we need, the mass, the grams of NO2. And you say, well, how do you know that for sure? It's always good to check your units. Because if you do, then you can dab on this. You know it's right. I end up with the grams of NO2 that I need. That's how we measure the mass. And so now I know all I have to do is the math. This divided by this. Now that gets a little bit tricky if you don't have a scientific calculator. And I didn't bring it for this video. I probably should have, but most students suffer not from the math, but just setting up the right equation. So just make sure 4.78 times 10 to the 24th divided by this and hit equals. Then whatever you get from that, you would multiply by 46.006, and you would have your answer. All right, I hope that helps. I'll shoot another one probably where I do have my calculator with me. But the main battle is usually setting this equation up. It's not the math that usually trips students up. Bye-bye.